On pages 11 through 14 of our Unit 5 notes, we are solving systems using a strategy called elimination. Elimination is a really nice strategy when it works out, when the equations are set up nicely, because when you rewrite the two equations vertically stacked, you are able to add them together. It's okay to add them together because we're simply adding two equivalent expressions to the left and right side. So we can add 6x minus 5y to the left side, add negative 9 to the right side. We're adding the same thing to both sides. And when we add, we will have 5y minus 5y. Those two terms will add to 0. 2x plus 6x gives us 8x. 17 plus negative 9, or 17 minus 9 is 8. So right here's the beauty of elimination. A beautiful, straightforward one-step equation. X equals 1. We now need to find the other variable. We do that by plugging in 1 for x into either of the equations. It doesn't matter which one. Neither one is particularly difficult or easy. And we have basically a two-step equation. So y just equals 3. When we write our ordered pair, our solution is always an ordered pair, an x value and a y value that both make both equations true. Make sure that you write x first and then y. Elimination has a lot of opportunities for error, so I would highly recommend, at least on assessments, that you always go ahead and plug your x and y back into your original equations and make sure that they check out. 6 minus 15 does equal negative 9. So that is the correct solution. X equals 1, y equals 3. This first example is already set up. When I add them together, the y terms will add to 0, just like on the left, and we will have a one-step equation. In the second example, we would need to first rewrite the second equation so that the x terms and the y terms are stacked. In this case, that involves transforming the equation. So subtracting 2x from both sides. And now we are ready to go. The x terms, the y terms are lined up. Same side of the equal sign. 2x minus 2x, or 2x plus negative 2x. Again, we just end up with a really, negative 26. Okay. We end up with a great one-step equation. Now, it's not always quite so straightforward. Oftentimes, we have to multiply one or both equations by a number in order to create coefficients that allow us to add to 0. So in this case, we could either multiply the first equation by 7, then we'd have 7x minus 7x, or we could multiply the first equation by 3, then we'd have 15y and negative 15y. I like to choose the smaller number, but either one is fine. So I'm going to multiply both sides of the equation by 3, not just putting a giant parentheses. We're multiplying the left side, parentheses, right side, parentheses. 3x plus 15y equals 27. So now when I add these two equations, 15y plus negative 15y, or 15y minus 15y, I end up, oh, I was supposed to do that step here. They're already lined up, so it's fine. Now when I add them up, I'm going to end up with negative 4x equals 24. One-step equation, nothing different than before. Solve for x. Whatever I get for x, I can plug into either equation and get y. Checking my solution. In this case, we really don't want to just multiply by 2 and then subtract. Subtraction is really not highly recommended because you often make a mistake and forget to subtract each term. I would suggest that you always multiply by even just negative 1 rather than subtracting, or in this case by negative 2, so that you can just go ahead and add the two equations together. If we multiply it by negative 2, it's ready to go. Negative 10x plus 10x we have negative 5y equals 30. Again, a one-step equation. We solve for y this time. Plug that y value back into either equation to get x. The hardest elimination case is when we have to multiply both equations by some constant in order to create coefficients that will cancel. Lots of choices here. I could multiply the first equation, both sides by 3. The second equation, both sides by negative 4. That's going to give me 12x minus 15y is 39 minus 12x. So here's what we're looking for. Same coefficient, one positive, one negative. Oh, this is a great one. When I add them, I get y equals 3. Now I could have also multiplied the first equation by negative 3, the second by positive 4. That would have still given me a negative 12 and a positive 12. Or I could have targeted the y terms and multiplied one equation by 4, the other by negative 5, or one by negative 4, the other by negative 5. Our goal is always this case. Same number in front of one of the variables, one positive, one negative. Same coefficient in one of the variables, one positive, one negative. Same coefficient, one positive, one negative.